Hello everyone, my name is Andressa Oliveira. I am a PhD student here at the University of Minho in Portugal. My work is supervised by Miguel, Azenha and José Granja, both from the University of Minho, but also by Motamedi from the Alcohol Technology Superior in Canada. The work that I'm going to present is a partnership between the University of Minho and Matosinhos City Hall, a town here in Portugal. The context where this partnership emerged is that we already know that BIM information modeling is an information management methodology and also a technology that uses 3D models filled with purpose-driven information important for the purpose that we're going to use it. And we already have a series of ISOs, of standards that support the implementation of BIM information modeling in the construction industry, also for the whole process of the construction industry. Specifically for the operational phase, we deal with the facility management discipline that has the objective of guaranteeing functionality, safety, and comfort for this facility. And as any other discipline within the construction industries, the implementation of BIM for facility management can have a lot of advantages. However, a scenario that we see today in the operational phase is that the FM systems, digital platforms are already implemented during the operational phase for the facility management to occur. However, not all of them have BIM capabilities or specifically the capability of visualization of three-dimensional models. And in this context, many of the time, the managers, the operators do not want to shift completely their system, not change for another platform, just to start having BIM in it, because they already have all the important information about managing those assets within these existing FM systems. In this context, Câmara de Matosinhos, or Matosinhos City Hall, decided to contact us to make a partnership with the objective of linking and integrating their existing FM platform, the IMMP, with the visualization of BIM models, specifically using the open format IFC. So the objective of the partnership was to develop a web platform where the managers and common citizens could visualize information models, and that would be linked with their existing FM system. However, to use and develop models to be seen within this platform, we also developed information requirements according to the necessary requirements for this purpose. And in the end, also an example of a BIM model for demonstration of the platform. For starting developing the platform and models and information requirements, first we needed to understand the requirements of Câmara de Matosinhos that included, for example, the visualization of the model, but also identification of the buildings and assets, the opening of requests for a specific asset. And from that, we decided we would have two pages, one for building selection, another for interaction page, and two different types, the managers, the ones that work in Câmara de Matosinhos, and also the common user, the citizen. For the platform itself, the front end would have the page layout, and we used the basic language, HTML, CSS, JavaScript, but specifically for the viewer and for interrogation interaction with the model in the IFC schema itself, we use the IFCjs library. For the backend, we use the Python Flask framework to access the platform through an API. And our information model, already developed based on our information requirements, was done in Revit, but exported according to IFC4 schema. To be able to make the integration that we want, we have two different data sources. So this our web platform is how we link the existing data source, it's the IMMP database. Within this database, we have all the management information we need about the assets and the building already there, already inserted, because Matosinhos is already using it. And now we are going to add another information that is this 3D model. And these two things need to be linked. And for them to be linked, I need to know within the model, how can I identify an element so I can have a specific and direct link to the IMMP database? How do I know that this chair in this room within this model is specifically this element within the database that already exists? So the objective here was to first select the relevant elements. So we need locations for locating the elements, the equipment, I'm sorry. And we need the equipment itself. It could be a chair, a table, a conditioner. And also we need the requests. Requests are those solicitations for actions. If I see a chair that is broken, I can make a request for maintenance for this chair. These are the elements that are important for us based on the features that they wanted for the web platform. So if you analyze the right side of the slide, if you analyze the IMMP database, we can understand how these elements are organized within it, and we could identify that they have, as any other database, a way of identifying uniquely those elements within there. For example, the locations all have a local underscore ID that represents the code generated automatically by the IMMP database to identify a location. And the same for equipment with element ID, and the same for a request, in this case called failure, with a failure ID. But if I want to link them, I need to find a way to identify those elements in real life. When you go to the other side, we could understand that Câmara de Matosinhos has already an inventory code, so they can organize the assets, the buildings, and everything. They already have a codification for it, and this codification can vary depending on the type of elements, depending on the location, but they are all inserted within the IMMP database under the full underlying code properties. So, for example, a chart that exists in real life, within the IMMP, it has an element ID associated that was created by the IMMP, but also has a property called local full code that contains the real life code that Câmara de Matosinhos gave it to it. So what we did after identifying this is organize this as information requirements, specifically using the level of information needs methodology. So there were tables with telling the user or the person that is going to develop the model to be used in the platform, which information should have in the model, how the model should be done and developed. So for example, here we can see the level of information needs table for architectural elements, equipment, and location. For the equipment, we know that it needs to have a simplified error shell, that the column must be similar to reality. But if you go to an alphanumeric information, that's the important part for the linking. All the elements, all the equipment actually should have a property called Código Matosinhos that within its content, we have that code, that full code that is the inventory code Matosinhos already uses in real life. When the equipment within the model has this code, I can investigate it and then make a direct link and map it to the IMMP database. So when someone is using the web platform and selects a chair, this chair will have all the information that it's not in the model, it's there in the IMMP database. So what's happening is basically we have just two database models in the IMMP, and then I have in the back end a mapping between the elements. On the front end, the user can see the model, we can interact with it. And if we can check the next slide, we can see how the platform appears for the user. So we have a main page where it's possible to see the building in 3D vision, per floor also, as you can see in letter C. We can select an element, how you can see in letter B. Letter D shows the information of the total amount of requests related to this building. Letter E shows information specifically of the equipment selected, in this case a chair. So we have the type, the category, the code, and the total number of requests. And on the letter F, you can see the forms that appears to the user if they select an element and they want to make a request. So this chair has a broken leg, and I want to tell Câmara de Matosinhos that it has a broken leg, so I do it. And when the user does it, the number and of failures associated to the element to the build updates itself. So in conclusion, what we have here is a detailed procedure that can be replicated where we took an existing FM system and added the capability of 3D vision using the web as the integration for both of them. And this is an advancement because there is no need to alter the measurement system, adopt different platform. It's prepared for digitalization and to have the BIM advantages that we wanted. Thank you very much, and don't hesitate to make any questions or to even contact us if you need. Thank you.